Good morning, students. In this video today I'll discuss about the chapter 7 of class 7th chemistry. The topic is air and atmosphere. So first you have to know what is air. Air is a mixture of different gases in which to some extent dust particles and water vapor also present. And what is atmosphere? Atmosphere is the blanket of air around the earth. Okay, so our earth is surrounded by a blanket of air which is known as atmosphere. The blanket of air around earth is known as atmosphere. Now see the composition of air. I have told air is a mixture of different gases. In air, dry air contains almost 78.09% nitrogen, 20.95% oxygen and 0.92% argon and a very little percentage 0.4% carbon dioxide and other gases by volume. The air also contains variable amount of water vapor and dust particles. Okay. So this is the composition of air. In air, almost 78% nitrogen, 20.95% oxygen, 0.92% argon, 0.04% carbon dioxide and to some extent dust particle and water vapor also present. This is the composition of air, and the composition of air varies from place to place and it does not have a formula. Therefore air is a mixture, not a compound, because the composition of air varies from place to place and it does not have a formula, chemical formula of air. Therefore air is a mixture, not a compound. So first constituent of air is nitrogen. It is present 78.09%. Nitrogen was discovered by Daniel Rutherford. Nitrogen gas was discovered by Daniel Rutherford in 1772 and was named in 1794. Nitrogen gas is mostly found in nature in free state. And nitrogen is very important element. It is essential for growth of plant and animals. Okay, so nitrogen is essential for the growth of plants and animals. It is an important constituent of chlorophyll, which is present in the cell of green plant. And nitrogen is also important for the production of protein in animals. So nitrogen is very important or essential element in living organisms for their growth of plants, growth of animals. Nitrogen is required. Now see, laboratory preparation of nitrogen. This is not required. Laboratory preparation of nitrogen, okay, not required. It is not important. Now see, uses of nitrogen. There are many importance of nitrogen. That is, in food industry nitrogen is used. Nitrogen is used for preparation of fertilizer. Okay, nitrogen is used to prepare medicines. Okay, so first use of nitrogen in food industry. Nitrogen being non-toxic gas, and nitrogen is used to preserve food. Nitrogen is used to preserve food items such as potato chips. Liquid nitrogen is also used as a refrigerant for freezing food. Okay, so in food industry nitrogen is used. In manufacturing chemicals like ammonia. Using nitrogen you can prepare ammonia gas. So when nitrogen react with hydrogen in presence of iron catalyst at very high pressure and temperature required 450 degrees Celsius almost, ammonia is formed. Okay, so the chemical equation is N2 plus 3H2 implies 2NH3. Using this reaction you can prepare ammonia gas from nitrogen gas. When nitrogen gas combined with hydrogen gas in presence of iron catalyst, temperature 450 degrees Celsius, and in presence of very high pressure, ammonia, that is NH3 gas, is formed. So for preparation of ammonia, nitrogen is required. Okay, and this process, preparation of ammonia, preparation of ammonia from nitrogen and hydrogen, this process is known as Haber-Bosch process. Using this process, you can prepare ammonia on a large scale. Detailed description of Haber-Bosch process is not required. Okay. Nitrogen is used to manufacture nitrogenous fertilizer such as ammonium nitrate. It is also used to make calcium cyanamide, that is CaCN2, which is a raw material for urea production, and urea used as a fertilizer. So nitrogen is indirectly used as a fertilizer because it is used to manufacture different nitrogenous fertilizer like ammonium nitrate, okay, calcium cyanamide, urea. To prepare all this fertilizer, nitrogenous fertilizer, nitrogen is required. Okay, so nitrogen is also used in the manufacture of compounds like TNT, trinitrotoluene. It is an explosive compound, TNT, nitrocellulose, trinitroglycerin. To prepare all these explosive substances, nitrogen is used. Nitrogen and medicine. Nitrogen is used in making a wide variety of medicine, including antibiotics. So nitrogen has many important uses like in food industry, in preparation of many chemicals, in preparation of nitrogenous fertilizer like ammonium nitrate, calcium cyanamide, urea. Nitrogen is used to prepare different explosive substances like TNT, nitrocellulose, trinitroglycerin. To prepare these explosive substances, nitrogen is used. And nitrogen is used to prepare medicines like antibiotics. Now say renewal of nitrogen. Renewal of nitrogen in atmosphere. So renewal of nitrogen. Nitrogen is renewed in the atmosphere through the nitrogen cycle. Nitrogen gas is renewed in the atmosphere through nitrogen cycle. So what is nitrogen cycle? Nitrogen cycle is the circulation of nitrogen between the atmosphere, soil and living organisms. Nitrogen cycle is the circulation of nitrogen between the atmosphere, soil and living organisms. Okay, and nitrogen cycle includes 5 steps. First step of nitrogen cycle is nitrogen fixation. Second is assimilation of soluble nitrates. Third step of nitrogen cycle is ammonification, and fourth step of nitrogen cycle is nitrification, and fifth is denitrification. These are total 5 steps of nitrogen cycle. Nitrogen cycle, what is nitrogen cycle? It is the circulation of nitrogen between the atmosphere, soil and living organisms. So first step of nitrogen cycle is nitrogen fixation. What is nitrogen fixation? Nitrogen fixation is the process. It is the process by which free nitrogen in the atmosphere converted into soluble nitrogen compounds, usually nitrates. Nitrogen fixation is the process by which free nitrogen in the atmosphere is converted into soluble nitrogen compounds, that is in nitrates form. Nitrogen is converted into nitrates, and these nitrate compounds can be easily absorbed by plant from the soil. Nitrogen fixation can take place in two ways during nitrogen cycle. First, the nitrogen in the air is converted into soluble nitrates with the help of nitrogen fixation bacteria. Nitrogen fixation can take place in two ways. One way is the nitrogen in the air is converted into soluble nitrate with the help of nitrogen fixing bacteria like rhizobium. Nitrogen fixing bacteria like rhizobium by the process of nitrogen fixation. Nitrogen fixing bacteria are found in the root nodules of leguminous plants such as peas, beans, and pulses. These nitrogen fixing bacteria convert nitrogen into in the air into ammonia, and then ammonia into nitrate. Nitrogen fixing bacteria converts nitrogen into ammonia, and then ammonia into nitrates. And these nitrates are used by the plant to make proteins. Nitrogen fixing bacteria thus provides nitrates to plant. Nitrogen fixing bacteria provide nitrates to plant in return of food and shelter. The relationship where the plant and bacteria are usually when the plant and bacteria are mutually benefited is known as symbiosis. Important term, what is symbiosis? Symbiosis, the relationship where the plant and bacteria are mutually benefited is known as symbiosis. And second method of nitrogen fixation is nitrates are also formed during the natural lightning process, and the nitrogen in the air combines with oxygen to form nitrogen dioxide. Nitrogen dioxide then combine with rainwater to form nitric acid, and nitric acid dissociate to provide nitrates to the soil. Okay, so these two are nitrogen methods of nitrogen fixation. A systematic diagram of nitrogen cycle is given. Diagrammatic representation of nitrogen cycle, you can see this is the nitrogen cycle. Next step of nitrogen cycle is assimilation of soluble nitrate. Assimilation of soluble nitrate. Soluble nitrates present in the soil are absorbed by plant through their roots, and they are converted into proteins. Animals consume plants and thus take in and assimilates protein into their bodies. Next step is ammonification. Certain bacteria decomposes the remains of dead plant and animals and break down protein to release ammonia, and this process is known as ammonification. Certain bacteria decompose the remains of dead plant and animals and break down protein to release ammonia, and this process is called ammonification. Next step is nitrification. What is nitrification? Nitrosomonas bacteria converts ammonia. Nitrification. Nitrosomonas bacteria converts ammonium compound into nitrates, and nitrobacter bacteria converts nitrate into nitrites into nitrates. Nitrosomonas bacteria converts ammonium compound into nitrites ammonium compound to nitrites, and nitrobacter bacteria converts nitrites to nitrate, and this process is called nitrification. Okay, nitrification. Where one term is given, denitrification. The remaining nitrates present in soil are acted upon by Pseudomonas bacteria. Remaining nitrates present in the soil are acted upon by Pseudomonas bacteria, which converts nitrate into free nitrogen, and this process is called denitrification. And the free nitrogen is released into the atmosphere by the process of denitrification. Okay, so these are the steps involved in nitrogen cycle. All term, all definition and name of bacteria, each type of bacteria you have to read. Now see, next element is oxygen. Oxygen is present almost 21%. Okay, oxygen is the second most abundant gas in the atmosphere. Oxygen was discovered by Carl W. Seeley and Joseph Priestley and Anthony Lavoisier. The oxygen gas named oxygen by Lavoisier. Okay, and oxygen is found in both in free state and in combined state in nature. Now the preparation of oxygen, O2, preparation of O2. Oxygen can be prepared in laboratory from hydrogen peroxide, potassium chromate, metal nitrate, air and water. There are many methods of preparation of oxygen. So first method of preparation of oxygen is from hydrogen peroxide. Hydrogen peroxide decomposes to give water and oxygen in presence of manganese dioxide catalyst. Okay, the chemical equation is, in laboratory manganese dioxide is used as a positive catalyst, for decomposition of hydrogen peroxide into water and oxygen. Hydrogen peroxide means H2O2. H2O2 is hydrogen peroxide. Arrow on decomposition it gives H2O, that is water plus O2. Okay, so oxygen can be prepared in laboratories by the slow decomposition of hydrogen peroxide using manganese dioxide as a catalyst. Okay, manganese dioxide increases the rate of the reaction. Second, preparation of oxygen from potassium chlorate, that is KClO3. Potassium chlorate, KClO3. When potassium chlorate is heated with manganese dioxide, potassium chlorate, that is KClO3, is heated with manganese dioxide, potassium chloride, that is KCl, and oxygen O2 are formed. Okay, so heating of potassium chlorate, KClO3, gives potassium chloride and oxygen gas, and in this reaction also manganese dioxide acts as a catalyst. Okay, so preparation of oxygen from potassium chlorate. And from metallic nitrates, preparation of oxygen from metallic nitrate like sodium nitrate, potassium nitrate. When these metals are heated, oxygen gas is produced. When metal nitrate like KNO3 or NaNO3, these metal nitrates are heated, then you will get oxygen and metal nitrite. Okay, that is preparation of metal and oxygen from metal nitrates. Now the properties of nitrogen. Properties of oxygen. Oxygen, it is a colorless, tasteless, odorless gas. It is slightly heavier than air. It is soluble in water than nitrogen. It is more soluble. Okay, and it is neutral to litmus. Now see, reaction of oxygen with metals, not important. When oxygen reacts with metal oxide are formed. Like when sodium reacts with oxygen, sodium oxide is formed. Calcium reacts with oxygen, calcium oxide is formed. Okay, reaction of oxygen with non-metals, it is also not important. Reaction of oxygen with non-metals, like when carbon reacts with oxygen, carbon dioxide is formed. When sulfur is react with oxygen, sulfur dioxide formed. That is, metal oxides are formed. Okay, and rapid oxidation, it is also known as combustion reaction. Combustion reaction is rapid oxidation. That is, burning of fuel is an example of rapid oxidation. Rapid oxidation In the type of oxidation in which oxygen react very quickly with a substance with the release of heat, light, energy is called rapid oxidation. This is also called combustion. For example, wood, coal, kerosene, petrol, LPG, candle wax undergo rapid oxidation or combustion along with release of carbon dioxide, water vapor and energy. So burning of any fuel is an example of rapid oxidation or combustion reaction. And slow oxidation, example of such type of slow oxidation, this is also chemical reaction of oxygen. Okay, so rusting of iron, respiration, these are slow chemical process, slow oxidation. Slow oxidation is the very slow process and energy is released slowly. Example, respiration, rusting. When iron comes in contact with atmospheric oxygen, and moisture, over a time a reddish brown layer of hydrated ferric oxide Fe2O3.NH2O is formed, and this reddish brown layer of hydrated ferric oxide is known as rust. And the process of formation of rust is called rusting. Rusting of iron. It is a chemical change. It is a slow oxidation reaction between iron and oxygen. Okay. Use of oxygen given different uses. Oxygen is used in oxyacetylene torch. Okay, oxyhydrogen torch. It is oxyhydrogen or oxyacetylene torch used for welding and cutting metal. It is used in the manufacture of iron and steel. Oxygen is used. And renewal of oxygen. Oxygen is renewed in the atmosphere by the process of photosynthesis. Okay, photosynthesis is a process by which green plants prepare their food, and oxygen is released in this process. Okay, thank you, students.